Object is beyond the center of curvature. Okay. Now don't draw, don't write, and just listen. So මේ තියෙන අපේ principal axis එක. දැන් මේ ටික මම draw කරන්න එපා. This is our principal axis. Then this is my mirror. Just to show that it's a concave mirror, I will draw the shape of the mirror here. Just to show that this is a concave mirror. Okay. And then here I have my focal point. So 2 squares gap එකක් තියලා තමයි මම focal point එක යන්නේ. This is pole P. So Sajish, I'll call you Randev. මට first name එක පැටලෙනවා වගේ Randev. So Randev, we are doing the light lesson, which is the 5th lesson. Up to that point, no, 4th waves lesson we are yet to do, but we are doing the 5th lesson light now. And last week we started the lesson and we are like doing mirrors. Mirrors well we started, and today is the second day of the lesson. So you might not like fully understand most of the things we do, but try your best to understand. And if you have any questions, you can ask. Okay. So this is the focal point and this is the center of curvature. Okay. Now our object is beyond the center of curvature, right? So if you remember, initially our object was here. One object එක location එක හැමලෙම වෙනස් වෙනවා නේ. Initially our object was here. Here කියන්නේ කොහෙද? Between the mirror, which is pole, and the focal point. Then our object was on the focal point. Then our object was between the focal point and the center of curvature, which was our third ray diagram. Then our fourth ray diagram was the object was on the center of curvature. Now our fifth ray diagram is object is beyond the center of curvature. කියන්නේ object එක තවත් ඈතට ගිහිල්ලා. Right, the object is beyond the center of curvature. Since this is our object, I will mark this as O. Right, I will mark this as O. This is my object. Now we have to use the ray diagrams and see how the image is formed. Okay. Hari, අපි use කරපු rays මොනවාද? එකක්, if you all remember, parallel light ray එක, when you send a light ray parallel, it will be reflected through the focal point. When you say when you send a parallel light ray, it will be reflected through the focal point. Do you all remember that? Give me a thumbs up if you remember that ray. If you send a parallel light ray, it will be reflected through the focal point. What about others? Hammer week you have to revise what you did the previous week. Even if you don't like 100% memorize it, at least you have to revise and come. Okay? Sorry. So this is the parallel light ray. So this will be reflected through the focal point. So like this. This is the first light ray. Is this clear, Lamai? I'll ask you one by one. Is this clear? Thumbs up. Everybody. When you send a parallel light ray, it is reflected through the focal point. Okay. Then අනිත් එකට use කරන්න පුළුවන්. Echo, when you send a light ray through the focal point, it is reflected parallelly. ඒක use කරන්නත් පුළුවන්. එහෙම නැත්නම්, remember, if you send a light ray through the center of curvature, it will be reflected along the same path. ray එක මතකයිද? If you send a light ray through the center of curvature, it will be reflected along the same path. Do you remember that? Yeah? Okay. මම ඒක use කරනවා. ඔයාලා අනිත් එක use කරන්නත් පුළුවන්. Like focal point එක through යන එකේ නම් parallel reflect වෙනවා කියන එක use කරන්නත් පුළුවන්. So I'm going to use center of curvature through යන එකේ නම්. I mean, of course, center of curvature through යන එක න object එකේ head එක through යන්න එපා. So something like this. So this light ray goes through the head of the object and through the center of curvature. It hits on the mirror and it will be reflected along the same path. Is that clear? A light ray that goes through the head of the object, it goes through the center of curvature, strikes on the mirror and reflects along the same path. Okay. And we know where the image is formed is where the two reflected light rays meet. බලමු අපි reflected light rays දෙක. එකක් තමයි, this is one of the reflected light rays. mirror එකේ වැදිලා reflect වෙච්ච light ray එකක්. අනිත් එක තමයි මෙයා. So where do they meet? They meet here. එහෙනම් this is where our image is formed. Let me explain this one more time. Our object is positioned beyond the center of curvature. You send a parallel light ray, it will be reflected through the focal point. So this is the reflected light ray. You send a light ray through the center of curvature, it will be reflected along the same path, like this. So where the two reflected light rays meet is here, you draw the image here. Okay? Is that clear, Lama? Is this ray diagram clear to you? If you have any questions, please do ask. Randev, did you at least get an idea? Okay, okay. Mayumdi, Rashmika. All right, okay. And now we will write. Ogalan draw කරන්න පටන් ගන්න. Okay, first of all, before you draw, tell me what are the properties of this image? What
Real.
are real? Why do we call this real? Because now if it is spread behind the mirror, we call it virtual, no? But here this is formed in front of the mirror. Can you see this image through the mirror?
Yes.
No. We can see an image through the mirror only if the image is formed behind the mirror. Here the image is formed in front of the mirror, so you cannot see it through the mirror. And how can I see this image? කොහොමද මම image එක බලන්නේ? Anybody? Okay, Mayumdi. Not thumbs up. What I want to know is, this is a real image. Real image එකක් කවදාවත් ඔයාට mirror දැන්. If I stand in front of a mirror, I can see my reflection through the mirror. But here, this image, it's a real image, so you can't see the reflection through the mirror. Virtual now, you see the reflection through the mirror. If it's real, you cannot. So then, how can you observe this image? I got one answer. Come on, Lamai. We did this last week. Out of 10, how can I only get one correct answer? Metna, Tinura, Ashwita, Miheli, Ashoda, Risindi, Rashmika, Evindi. What do you think? Yes. It's a real image. Real image එකක් නම් ඔයාට white color screen එකක් use කරන්න වෙනවා. Because the image will be formed on a white screen only. ඔයාට mirror එක ඇතුලෙන් image එක පේන්නේ නැහැ. Just like when I stand in front of a mirror, I can see my reflection because it's a virtual image. ඒ කියන්නේ image mirror එක පිටිපස්ස image එක හදුනොත් it's a virtual image. So you can see the reflection through the mirror. But here, this is a real image, so you can't see it through the mirror. You have to use a white color screen. එහෙනම් This is a real image. What are the other properties of this image? Inverted. It's upside down, so we call it inverted. What else?
Real, inverted, smaller than the object.
Smaller than the object. That's very important because now all this time, first ray diagram में के, second ray diagram में के, and third. Yes, Ashwita.
We can say it like if it is larger, we can say enlarged, and if it is smaller, diminished also we can say.
Yeah, diminished. We can say diminished. When it's larger, we can say enlarged. We can say magnified. When it's smaller, you can say diminished. Or we can say smaller than the object also. So in the first ray diagram, second ray diagram, and third ray diagram, image එක හැමලෙම ලොකු වුණා object එකට වඩා. So we call the image magnified, or we said it's larger than the object. In the fourth ray diagram, the image was the same size as the object. Image was the same size as the object. Now here, image is smaller than the object, right? So, location of the image is amuli location between the focal point and center of curvature. And properties of the image, real, inverted as you all said, and smaller than the object, we call it diminished. May ray diagram එක 100% clear ද?
Yes, station.
Everybody? Good. Can you all draw this? Draw and write this real fast. I'm actually doing the class a bit remotely because I'm not at home. I'm at our factory. So, podi hari connection. If I'm lagging, let me know because the connection is pretty strong, but you know, duck signal had matter. So if I'm lagging, let me know. I will set a timer for 6 minutes. It is laggy. Tinura, can you hear me now? Now is it okay? Hi, okay. Okay, start writing lamai. මගේ ඇති වැරදිලා 1 minute එකක් වැඩි වුණා, but quickly finish. Lamai, while you write this, my connection is unstable, so I'm going to switch the network. I disconnected. Just be patient. Huh? You can keep writing. Can somebody tell me if y'all can hear me now? Give me a thumbs up. Aha. Okay. All good. Okay. Okay. Done. Time is almost up. I hope you have finished writing. We have one more condition for where the object could be, right? So at the beginning, in the very first ray diagram, we said object is between the mirror and the focal point. Then we said object is on the focal point. Then what happened when the object was on the focal point? Where was the image? When the object was on the focal point, where was the image?
The image was back of the mirror.
No.
Yeah.
When the object was on infinity, where was the... Yes. I just said the answer. But yes, I got the answer in the chat box. It's actually infinity. When the object is on the focal point, image is at infinity. Okay. Then we said in the third ray diagram, object is between the focal point and center of curvature. Then we said object is on the center of curvature. In the last one, we said object is beyond the center of curvature. We have a sixth condition, but here we are not going to draw a ray diagram, right? We are not going to draw a ray diagram because that's impossible. This is when the object is very far away. We assume that the object is at infinity. Object is very far away. We assume that it's at infinity. Now when the object is at infinity, there is no way that you can draw the object, right? Because how can you draw infinity? Ekin api mekata ray diagram එකක් අඳින්නේ නැහැ. But api location එකයි properties we වෙනම study කරනවා. So you have to remember the location of the image and the properties of the image. However, you don't have to draw the ray diagram. So as I said, when the object is on the focal point, the image was at infinity. Right? When the object was on the focal point, image was at infinity. Now, when the object is at infinity, image is formed on the focal point. ඒකට මම හොඳ practical example එකක් අපි කරමු ඉස්සරහට, but that's coming in a bit. දැනට මම කියනක හොඳට අහගන්න. When the object is on the focal point, image is at infinity. Now, when the object is at infinity, image is formed on the focal point. So location of the image is on the focal point. Okay. And properties of the image are like this. It's going to be a real image. It's going to be an inverted image. And it's going to be smaller than the object. So we call it diminished. So as I said, these are not things that you can draw the ray diagram for. You just have to memorize this. But it's easy for us to memorize when we think of it like object එක focal point එකේ image එක infinity නම් image object එක infinity එකේ image එක focal point කියන එකෙන් අපිට ඒක තේරුම් ගන්න ලේසි. It's easy for us to memorize in that way. Is that clear to you, ළමයි? Is that clear? Others? ඕගන් තේරෙනවද නේද අපිට මේකට ray diagram එකක් අඳින්න බෑ කියලා? It's impossible, no? There's no way we can diagrammatically show infinity නේ ඒකයි. හැබැයි මම ඉස්සරහට පොඩි අපි practical එකක් කරනවා. ඒකෙදි මම කියන්නම් I'll talk about this a bit more, but for now this is what you have to understand. Okay. Okay. Can you all quickly copy this down also? Quickly copy this down. Sixth one also quickly copy down. Just 2 minutes. I'm sorry, Lamai, I got disconnected. Let me share the screen again. Can you all hear me? Okay.
Yes, teacher.
Okay.
Yes, teacher.
Yes, teacher.
Okay. I told you there's a bit of a connection problem, but give me a second. The screen is being shared. Were you able to write what I gave? Were you writing? Okay, quickly write this, Lamai. Quickly write this. Done writing, Lamai? Thumbs up? Okay. Okay, let's move on, no? So that is about concave mirrors, right? So we have been talking about concave mirrors since last week. We talked about the basic reflections, and then we learned about the ray diagrams, how images are formed, right? Sorry. So now we are going to be talking about convex mirrors, right? So all this time we were talking about concave mirrors. Now we are going to be talking about convex mirrors. Can you all put a subtopic, convex mirrors? Convex mirrors. Okay, so in convex mirrors also, we are going to be first learning about the basic reflections, right? Now, but unlike concave mirrors, in convex mirrors, the basic reflections are going to be a little different. Let's see how they're going to be different. Do you remember, can you flip the pages and see where we drew about the convex and concave mirrors and how they are formed? අර අපි sphere එකක් ඇඳලා sphere එකේ කොහොමද concave mirrors, convex mirrors හැදෙන්නේ කියලා draw කරා නේද? ඒකට ගියන්න බලන්න මේ page එකට පෙරලන්න බලන්න. Can you tell me is the focal point in front of the mirror or behind the mirror in a convex mirror? Is the focal point in front of the mirror or behind the mirror in a convex mirror? Okay. Yes, Mihaly. Others, what do y'all think? Is the focal point in front of or behind the mirror in a convex mirror?
Teacher, can I get the question again?
Yes. Is the focal point in front or behind the mirror in a convex mirror? Yes, Tinura?
Teacher, behind the mirror.
Okay, Ashita says behind the mirror. Others? Mayundi says behind. Yes. It is behind the mirror. What about the center of curvature? Yes, Evindi. What about the center of curvature?
It is also behind.
It is also
It
behind.
is also behind.
Yes. So, Mukud draw karane pa just balagana. We have the principal axis like this. And we have the mirror like this. Now, I told you, even though we use like a dash line to show the mirror, api mirror ke kane. Mulu line එක mirror එක පෙන්වුවාට mirror එක මොකද්ද කියලා පෙන්වන්න ඕනේ. We just draw the shape a little bit, right? So මෙහෙමනේ convex mirror එකක් එන්නේ. It's curved outwards. So මෙන්න මෙහෙම තියෙනවා. So our focal point is behind the mirror. So මෙන්න මෙතන focal point. So mirror එකේ මෙන්න මෙතන තමයි අපි pole කියලා කියන්නේ. Pole, right? So from pole to focal point, there's a gap of 2 squares. And focal point in the center of curvature වලට there's a gap of 2 squares. So this is how the convex mirror works. Make it thereunnada the setup, is it clear? Is the setup clear? Hari. We are going to be learning the basic reflections first, right? Make a mama අපිට ray diagram එක අඳිද්දී sides පොඩක් switch it's okay, we'll just draw it like this. Hari. First of all, we are getting a parallel light, we are getting a light ray along the principal axis. මෙහෙම light ray එකක්, sorry. We are getting a light ray along the principal axis. Then this is the mirror. It strikes on the mirror and it will reflect along the same path. So it will reflect along the same path like this. Okay. A light, just like the concave mirror, right? When you send a light ray along the principal axis, it strikes on the mirror and it's reflected along the same path. Same thing happens here. Make it clear this is the first basic reflection. Is it clear? I'm going to keep asking because I told you light is a difficult lesson. Hard. Then our second basic reflection. I'm going to send a light ray parallel to the principal axis. In a concave mirror, when I send a light ray parallel to the principal axis, it was reflected through the focal point. That was a concave mirror. In the convex mirror, do we have a focal point at the front of the mirror? අපිට මේ mirror එක ඉස්සරහා focal point එකක් නැහැනේ. එහෙනම් මොකද කරන්නේ? When you send a parallel light ray to a convex mirror, it cannot reflect through the focal point because there is no focal point in front of the mirror. Then it will reflect as if it is coming from the focal point. Focal point can reflect whenever වගේ මෙහෙම reflect. Same straight line, but may back of the mirror hinda mama dash line එකෙන් අඳින්නේ. But when you send a parallel light ray to the convex mirror, it will be reflected as if it is coming from the focal point. Did you understand that? Concave mirror එක නම් කෙලින්ම. But මේක කෙලින්ම බෑනේ. මොකද at the front of the mirror there's no focal point. මම තව එකක් draw කරන්නම්. තව මෙන්න මෙහෙම parallel light ray එකක් යවනවා. යටිනුත් යවනවා. මෙයාත් reflect වෙනවා as if it is coming from the focal point. Yes, one second. Okay. If it was a concave mirror, when you send a parallel light ray, දැන් මෙන්න මම පැත්තෙන් පොඩි sketch එකක් අඳින්නම්. If it was a concave mirror, when you send a parallel light ray like this, it will be reflected through the focal point. මෙහෙම focal point එක through what am I drawing? One second, lamai. This will be reflected through the focal point because the focal point was at the front of the mirror. So reflect when a lace. The method when the parallel light ray strikes on the mirror, it obviously reflects. No? But reflect with the art go through kind of focal point. If the focal point was here, it would have been able to go through the focal point like this. But the focal point is at the back of the mirror. Then reflect when as if the light ray is coming from the focal point but outwards. Elia පැත්තට තමයි reflect වෙන්නේ. Here also the same. So make a straight line එකක් විදියට draw කරන්න ඕනේ, but back of the mirror part එක you draw using dash lines. Front of the mirror you draw a bold line. Mind, is it clear? Okay. Then, one second. Okay. Then next one. You are going to send a light ray to the center of, okay, sorry. You are going to send a light ray as if it is coming to the focal point. ඒ කියන්නේ මොකක්ද? මෙන්න මෙහෙම. නිකන් focal point එකට එනවා වගේ ඔයා light ray එකක් send කරනවා. Right? You are going to send it because you can't send a light ray through the focal point. Ne? In a convex mirror, it's impossible to send a light ray through the focal point because the focal point is not at the front of the mirror. It's at the back. So you're going to send a light ray as if it is coming to the focal point. එහෙම එන light ray එක reflect වෙන්නේ parallel to the principal axis. It's reflected parallel to the principal axis. Okay? It's simple. Focal point එකට එනවා වගේ light ray එකක් එනවා. ඊට පස්සේ ආ මෙහෙම mirror එකේ වදිනවා. ඊට පස්සේ ආ parallelly reflect වෙනවා. Focal point එකට එනවා වගේ light ray එකක් මෙහෙම එනවා. But එයාට පිටිපස්සට යන්න බෑ because it's the back of the mirror, so it will be reflected parallel. අර focal point එකට එනවා වගේ අඳින්න ඕන හින්දා මම මෙහෙම dash line එකක් අඳිනවා so that I can keep a ruler and draw a proper line that is coming towards the focal point. But මෙතනින් එහාට light ray එකට යන්න බෑ. That's why I have drawn a dash line. Is it clear? Did you understand this, Namai? Okay. If you want to, we can draw another one here. Mamuli me dash line like this. A light ray is coming as if it's coming towards the focal point. It strikes on the mirror. From this point onwards, it cannot go further because it's the back of the mirror. So it will be reflected parallel to the principal axis like this. Okay? So this is the third basic reflection. Last basic reflection is, we have the mirror like this. Here, a light ray, then ඔගන්න මතකයිද concave mirrors බල When you send a light ray through the center of curvature, it is reflected along the same path. Center of curvature through යන light ray එක ඒ path එකේම අනිත් පැත්තට එනවා. දැන් මෙතන center of curvature through ඔයාට light ray එකක් යවන්න බෑනේ. Because the center of curvature is at the back of the mirror. එහෙනම් ඔයා light ray එකක් එවනවා as if it is coming towards the center of curvature. Center of curvature එකට එනවා වගේ light ray එකක් එවනවා. Okay? So you're sending a light ray as if it is coming to the center of curvature. But from this point onwards, it cannot go further because it's the back of the mirror. එයා reflect when it a path එකේම තමයි. So it will be reflected along the same path. If I show you another one, නිකන් මෙහෙම තව එකක් පෙන්නන්න උගලන්ට. You send a light ray as if it is coming to the center of curvature. From this point onwards, it doesn't go further. It will reflect back along the same path. Is this also clear to you, Lamai? Okay. My connections. Can you all hear me? Am I lagging? I don't know what's wrong with my connection today.
Okay, teacher, but
Not lagging, no? ළමයි මට කවුරු කියනවද lag වෙනවද කියලා? ඔයගොල්ලෝ මේ thumbs up දෙන්නේ lag වෙන්නේ නැහැ කියන එකද? I'm confused whether it's that you understood or whether you're saying that no, right? Okay. මට පෙන්නන my connection unstable කියලා. So for a bit I will keep my camera off. Okay, y'all can copy this down. I will set a timer for 8 minutes. Hurry. Time එකක් දාන්න. No, I won't set a timer. Can y'all let me know when you finish? Quickly do. Quickly start drawing. Lamai, you have 3 more minutes. Quickly finish. Done, lamai? Everybody? Give me a thumbs up if you have finished. Okay. Now that we have learned the basic reflections, we will see how an image is formed. Okay. How many ray diagrams did we draw in concave mirrors? How many ray diagrams did we draw under concave mirrors? Count and tell me, how many did we draw? Did we? Yes, we did 5. Yes. But good for you and good for all of us, in convex mirrors, we only have to learn one ray diagram. So we learned all the basic reflections. Using these basic reflections, we only have to draw one ray diagram. Okay. So can you write a subtopic, image formation. Write a subtopic, image formation. Okay. Now I have a question. In front of a concave mirror, if you remember, we had the focal point, we had the center of curvature in front of a concave mirror. Yeah? So we had the focal point, we had the center of curvature and all that. එතකොට අපිට object එක තියන්න එක එක locations ගොඩක් තිබ්බා, right? We could keep the object between the pole and the focal point. Then we were able to keep the object on the focal point. Then we were able to keep the object between the focal point and center of curvature. Then we could keep the object on the center of curvature and beyond the center of curvature and so on. But in front of a convex mirror, which is here, this one, there are no such locations, right? Then behind the mirror, අපිට මුකුත් objects තියන්න බෑනේ. Behind the mirror is not somewhere that we can access, right? So in front of the mirror, focal point, center of curvature, මුකුත් නැහැ. There are no such locations. ඒකෙන්ද අපිට එක ray diagram එකයි තියෙන්නේ. So we just keep an object like this. We just keep an object like this. Did you understand what I said, Lamai? Can you all give me a thumbs up if you understood? Others? Okay. So let's draw our ray diagram and see. දැන් මේක මම textbook එකේ තියෙන එකත් එක්ක ඔයගලන් පටලව ගන්න එපා. textbook එකේ mirror එක අනිත් පැත්ත හරවලා තියෙන්නේ, right? side එක එහා පැත්ත කියන්නේ. mirror එකේම මේක opposite side එකට හරවලා තියෙන්නේ. දැන් මගේ එකේ තියෙන්නේ අනිත් පැත්තට. That is the same thing, okay? Now I have to use two of my basic reflections. මම එකක් use කරනවා parallel යන light ray එක. Here you can see, when you send a parallel light ray, it is reflected as if it's reflected from the focal point. When you send a parallel light ray, it is reflected as if it's reflected from the focal point. එහෙනම් මෙන්න මෙතන I'm gonna send a parallel light ray. I'm gonna send a parallel light ray. This light ray will reflect as if it is reflecting from the focal point. So this is my focal point now. මෙයාගෙන් reflect වෙනවා වගේ මෙන්න මෙහෙම reflect වෙනවා. See? Like that. Same straight line. මේ ray එක clear ද ළමයි? Give me a thumbs up if you understood. Others? Okay. Then the other ray that I am using is when you send a light, make a fourth. When you send a light ray towards the center of curvature, it can't go to the center of curvature because it's the back of the mirror. But when you send it towards the center of curvature, it will be reflected along the same path. එහෙනම් ඒක තමයි මම අනිත් එක draw කරන්නේ. So, one second. I'm going to send a light ray like this, as if it is going towards the center of curvature. As if it's going towards the center of curvature, like this. See, light ray ka kya banwa? As if it's going to the center of curvature. It strikes on the mirror and it will reflect along the same path, like this. One second. Why can't I? One second, I can't move my right. Okay. It will reflect along the same path. Did you understand the second ray also? All clear? Give me a thumbs up. Hi. Now let's look at our reflected light rays. May ape ek reflect vecha light ray ka, may anith reflect vecha light ray ka. Are they going to meet at the front of the mirror? Are they going to meet at the front of the mirror? What do you think? No, because can you see that they are going far and far apart from each other, no? They're going far and far away from each other. එහෙනම් අපි මේ දෙක පිටිපස්සට extend කරනවා. පිටිපස්සට කොහොමද extend කරලානේ තියෙන්නේ නේද? So when you extend, you can see they meet here. එහෙනම් this is where the image is formed. Can you tell me, is this a real image or a virtual image?
Virtual.
Virtual, because it's at the back of the mirror. So එකින්ද මම මෙහෙම dash line එකකින් තමයි යව පෙන්නන්නේ. This is the image. Object and image, right? එහෙනම් location of the image is very simple. Behind the mirror. That's it. Properties of the image. Virtual, as y'all said. What else? What else are the properties of the image?
Diminished.
Diminished, smaller than the object, diminished. What else? Upright, very
Upright.
good. Yes, upright. It's not inverted. It's not upside down. It's the same way as the object. So we say upright and it's smaller than the object. In other words, we can call it diminished. Is this clear? Is this clear to all of you? Others? Okay. Good. Can you all copy this down? Quickly copy this down. I will set a timer. Quickly write this down. I will set a timer for 7 minutes for both the picture and writing what's at the bottom. 7 minutes. Quickly write.
Teacher, we have to draw the image formation, that one in the notes, right?
You have to draw this ray diagram and you have to write what's underneath that. Okay? Okay, Ashwita?
Yes, teacher.
Okay, am I done drawing? Okay. Huh. Did we do that activity where like there's a tree at the outside and we're gonna focus the image on the on a white screen? Ek අපි කරාද? I'm just asking because I can't remember. I don't think we did it, no? No. Okay. එහෙනම් අපි ඒ activity එක තමයි කරන්න හදන්නේ, right? So put a topic, activity. One second, my mouse is stuck.
Tisha, did we finish this chapter today?
Sorry, Ashwita.
Are we able to finish this chapter today?
Finish the lesson?
Yes.
No, definitely not. This is a long lesson. We have to do lenses entirely. But next week we are going to finish this.
Because on 19th we are starting our term exams. That's it.
19th are starting term exams. Up to which lesson are you all getting?
Until 5th lesson.
May lie tooth included. Did you all cover until this point at school?
Yes.
Really? With the sports meet and everything?
We had it we had the sports meet during the month of January.
Okay. When did you start the grade 11 syllabus?
On the 2nd of January.
All right. Okay. Okay.
Now we are in refraction of light
We are at what?
in school. We are at the topic refraction of light at
Refraction of
school.
light. Okay. So, anyhow, I mean, we started in December also, but we have to make sure that everybody understands everything. No, so this is the best speed that we have been doing. But yes, of course, we missed one class. I do remember that, and I am going to be rescheduling another class for sure. Our school said there will only be 3 lessons for first term. Then you are saved. Our first 3 lessons karlana din until mixture, so then you are saved. ගොඩක් schools වල third lesson and fourth lesson තමයි තියෙන්නේ. But anyhow, අපි මේ කරන් යන විදියට කරමු, right? And even in the vacation, we are going to have classes for the missed class, which I think 2 weeks before we missed a class. ඒකේ extra class එක අපි අනිවාර්යයෙන්ම schedule කරනවා. මම ඒකට දවස තියාගත්තා. April 3rd, I think. Anyways, Good Friday දවස තමයි මම no, Good Friday නෙවෙයි, Poe Day, April 1st, no? Can somebody check a calendar? Let me check the calendar.
April 1st, we are having the poet issue.
April 1st is the Poe, no?
Yes.
April 1st තමයි මම හිතුවේ. Can
Third is also something public holiday.
April 1st is anyways full holiday and it's a Poe Day, no?
Yes.
Yeah. So do you all prefer April 1st or April 3rd? Either of the day, it will be like early morning, like 7:30 to 10 වගේ තමයි class එක කරන්නේ කොහොමද? If you want to, I can make it 7 to 9:30, depending on whether you can wake up at that time.
7 to 9:30.
7 to 9:30 is okay, no? In the morning?
Yes.
Yeah. Actually, 1st of April works better for me also. මොකද
Is
මට
the third? Can you click on third?
I have to check because I think I scheduled another class. I just have to check with my assistant. I think I scheduled another class for April 3rd. So I think I will have to do April 1st.
Then let's keep it on first teacher because they told that we are having vacation classes in school during April.
Okay, we'll see, no? Then අපි April 1st දෙමු. හදිස්සියේ කාට හරි miss වුණොත් මා අනිවාර්ය recording එක දෙන්නම්. But for now we'll keep April 1st, but I will double check. I don't think April 3rd තමයි මම හිතන්නේ මම ඒගොල්ලන්ට දුන්නේ Good Friday දවස. හරි, ඒක චුට්ටක් බලමු. එහෙම වුණොත් මම හරියටම double check කරලා group එකේ officially දාන්නම්. So we will see. Hari, activity. So we are going to see how to find the focal length of a concave mirror. Okay. How to find the focal length of a concave mirror. Okay. Now don't write anything. Listen very carefully. Right. So we are going to, we need a table for this. We need a table for this. Okay. On the table now, may I will a concave mirror. Okay. We are not using a convex mirror. We are using a concave mirror. The concave mirror එකක් නා you can't just randomly keep a mirror no අපි මොකක්ද stand එකක් තියන්න ඕනේ. So there are lens stands. මෙම lens එකක් lens හරි mirror එකක් හරි මෙම this looks a bit weird but let me redraw. There are like stands in the lab where you can stand a lens or a mirror. මෙම fix කරන්න පුළුවන්. So මේකට තමයි මම මගේ mirror එක fix කරන්නේ. This is my concave mirror. Okay, so if the object is at infinity, where is the image formed? If the object is at infinity, where is the image formed? In a concave mirror. If the object is at infinity, where is the image formed? Okay, I got one answer. What about others?
At focal point?
Okay, Ashwita says focal point. What about others? If the object is at infinity, where is the image formed? That's a very simple question because you can clearly refer to the note. Why am I only getting two answers? At the focal point. If the object is at infinity, image will be at the focal point. Now here what I'm going to do is, I'm going to try to find the focal point or the focal length. ඒ කියන්නේ මම හරි ඕගොල්ලන් කරනවා කියලා හිතන්න මම ඔයගලන්ට දෙනවා mirror එකක්. ළමයි this is a concave mirror, find the focal length of this mirror කියලා මම ඔයගලන්ට කියනවා. So you should be able to find the focal length on your own. එතකොට අපි මොකද කරන්නේ? If I select an object at infinity, the image will be formed at the focal point. No? ඒකෙන් මට බලන්න පුළුවන් focal point එක කොතනද තියෙන්නේ කියලා. ඒකට I need to have an object that is at infinity. So infinity as we know is not a real point. Infinity කියන්නේ පොර real point එකක් නෙවෙයිනේ අපි දන්න විදියට. However, සාමාන්‍යයෙන් අපි in practical, because in theory infinity is not a real point. Infinity is somewhere that we cannot imagine. Theory එකේ විදියට. හැබැයි practically අපි කියනවා infinity කියන්නේ ගොඩාක් ඈත තැනක්. If something is like very far away, we assume that it's infinity. Okay? ඒක හින්දා මම දැන් මේ lab එකේ right මේ lab එකේ මම table එක තියලා මගේ concave lens එක arrange කරලා තියෙනවා. This is my concave lens. I need an object that is far away. If I select an object that is far away, මට assume කරන්න පුළුවන් ඒ object එක තියෙන infinity කියලා. So මම මේ table එකයි lens එකයි everything I place this in front of a window. Lab එකේ window එකක් තියෙන්න ඕනේ. Window එකෙන් එළිය බැලුවාම you should be able to see a distinct object. එක්ක building එකක් හරි මොකක් හරි අර clearly පේන object එකක් තියෙන්න ඕනේ window එකෙන් එළිය. Now in this example, let's say it's a tree. එහෙම තියෙන තැනක තමයි මේක set up කරන්න ඕනේ. Right? You should have an object that you can assume is at infinity. This is not technically at infinity, but considering the lens එක මෙතන තියෙද්දි ගොඩාක් ඈත තියෙන object එකක් infinity වගේනේ. So ඒකින්ද අපි assumption එකක් කරන්න එතන. Right? So here our object is at infinity. Object is at infinity. Up to that point, is it clear?
Yes, teacher.
Okay. Now, what I'm going to do is, when I have my object at infinity and I have a concave lens, I know the image is formed at the focal point. Is the image a real image or a virtual image? Is it a real image
Actually,
or
can you repeat the question again?
is it a real image or a virtual image?
When it is formed at focal point.
Yeah, when the object is at infinity, image is formed on the focal point. Is it a real image or a virtual image? And I need answers from everybody. What about others? හැමෝම අහන් ඉඳලා හැමෝම උත්තර දෙන්න. I'm not getting enough answers. දැන් එක්කෙනෙක් දෙන්නෙක් හැමලේම answer කරනවා.
Virtual.
Very good. But what about others? Yes, Ashita.
Virtual.
Okay, Ashita says virtual. Miheli okay. Mayumdi okay. Others? Mitna okay. Evindi okay. Okay, Tinura. Risindi, එයාම last week එකත් එක්ක recordings එවන්නම්. Last week එක අදේකයි තෙවන්නම්. ඒතර ඔක්කොම එකට බලන්න, okay? So then you will get a more clearer picture. Okay. ළමයි දැන් මම මේ කියපු එක we wrote this no. මේ උඩ බලන්න අපි ලිව්වා up here. When the object is very far away at infinity, image is formed on the focal point. Image is real කියලා මෙතනම ලිව්වා. එතකොට how can you say it's virtual? It's a real image. Real image එකක් හැදෙන්නේ screen එකක් උඩ, right? So I have to use a white color screen. මම කියන මෙන්න මේ white color screen එකක් use කරනවා. Screen එකක් නිකන් randomly තියන්න බෑනේ, so I have to use another stand. පොඩි stand එක මෙන්න screen එකක් මම use කරනවා. This is a white screen. Now I have an object that is far away and I have my concave lens and I have a white color screen. I know that since the object is far away, so I assume that the object is at infinity, I know the image will be formed on the focal point. දැන් ඔයා මෙහෙම බලන් ඉන්න ඔයාට පේන්නේ නැහැ image එක. මම මොකද කරන්නේ? මෙහෙම white screen එක එහාට මෙහාට move කර කර බලනවා. කොතනදද image එකක් මේකට පේන්නේ කියලා. If you go up here, here the image is supposed to be real. එකේ white screen එකේ හැදෙනවා. It's supposed to be inverted and it's supposed to be smaller than the object. So මම එහාට මෙහාට මෙහෙම move කර කර බලනවා white color screen එක. Right? So, okay, Risimbi. මම මේ move කරද්දි මෙන්න මේ වගේ තැනක I can see a very a rough image of the tree. Upside down because it's an inverted image, you know. Inverted small image. Okay? I mean, obviously, මෙතන වාට නිකන් මාරම crystal clear image එකක් හම්බෙන්නේ නැහැ. Mirror එකක වගේ ගොඩාක් clear image එකක් හම්බ වෙන්නේ නැහැ when you're using a white color screen. But you can see somewhat a clear image. ඔයා හැරිමන් move කරලා බැලුවම ඔයාට එතන පේන clear image එක තියෙන තැන ඔයා නවත්තන්න. So here the image is formed. If the object is at infinity, we know the image is formed at the focal point. Now the image is formed here, no? Then this must be the focal point. This must be the focal point. Did you all understand, Lamai? Did you all understand this? Others? Yes, Tinura. So you need 2 lessons, no? Okay. So, if this is the focal point, we know The distance between the mirror and the focal point, we call it the focal length. So, our distance measure karahama, you get the focal length. This is focal length. අපි ඒකට මෙහෙම simple f කියලා කියනවා. Did you understand this experiment clearly? It's not an experiment, it's just an activity. Did you understand this activity? Anybody has any questions? No? Nobody has any questions, no? Okay, can you all quickly copy down this diagram? May diagram में copy करना इच्छा वाला होना है, I will give you like 3 minutes, 4 minutes. Quickly copy down the diagram. Then I will give you a few sentences to write. Quickly copy down the diagram. Done, Lamai? Give me a thumbs up if you have finished writing. Still writing. Mecherada? Others? Metna, Tinura, Yashoda, Ashwita, Mayumdi, Rashmika. Have you all finished writing? Okay. Let's just quickly write a few sentences. Mata Kamaliana. Okay, quickly write these 5 sentences. Just take 2 minutes and quickly write. Huh? Quickly write, Lamai. Done, Lamai? Okay. Anybody who needs more time? I think them will. Okay. Now we are done with the reflection. So, mom patanga de kiwa mana mataka hai. But in the geometrical optics lesson, which is our 5th lesson, the entire lesson is divided into 2 parts. First part is about reflection of light, where we talk about mirrors and all that. Then the second part is refraction of light, where we talk about lenses. Okay. So we are done with the first part and we are doing the second part today, refraction of light. Okay. Put a subtopic. It's quite a main topic, refraction of light. A reflection, so this is refraction of light.
Nisha, we should write this.
Write the topic, yes.
Nisha.
Yes, Ashita.
Nisha, today I would leave a little early because I have an exam at 9:30.
Okay. All right. Okay. So have you, let me know if you have noticed this. You take a glass of water. Now, this is filled with water. Okay. And you put a straw to drink water, right? Water because it's transparent, you can see through. So, at this water surface, it looks as if, one second, it looks as if the straw is like kind of broken here and there. Have you all noticed this? Give me a thumbs up if you have seen this in real life. Have you all seen this? Yeah, with a pencil. Yes. Anita, what about others? Yeah. Why does it look so broken at the water surface? Water surface air and here it's water. And at the surface of these two mediums, it looks broken. This is as a result of refraction of light. When a light ray is entering from one medium to another, nikang medium transparent medium. If light entering from one transparent medium to another transparent medium, the light ray bends. Light ray ka bend vena. It break pain. I will show you an example. Okay. This is not the real note. So let's say we have a glass tank of water. Okay, tank of water. Now, tank let's just say we have water. And outside we have air. So in the water, there is a fish. Let's say this is very clear water. The water is quite clear. So you can see the water, see the fish inside the water. I mean, if the water is clear, you can see the fish, not just the fish, whatever is underwater. If it's clear, you can see, right? So we have a fish in now. Fish I told you, whenever you're looking at an object, if you can see that object, that means light rays are traveling from that object to your eyes. Lesson luminous objects will directly light so like sun or light bulb or candle or whatever. Non-luminous objects luminous objects will light light even non-luminous objects, from those light travels to your eye. That's how you can see those. Any object, you can see it because light travels from that object to your eye. Do you all remember that? ඒ object එකේ ඔයාගේ හැට light rays එනවා. ඒකයි ඔයාට පේන්නේ. මතකයිද ඒක ඔයගලන්ට? මතකයිද? No? Others?
Yes, teacher.
Yes. එහෙනම්, if you can see this fish means that light rays are traveling from this fish to your eye. Let's see how this happens. මෙන්න මෙහෙම එක light ray එකක් එනවා from the fish. ඇවිල්ලා here now there are two transparent mediums. මෙතන medium එක change වෙනවා. Medium එක change වෙද්දී light ray එක චුට්ටක් bend වෙනවා. See? The light ray is bending. Very slightly the light ray. Could be very slightly, නැත්නම් ගොඩක් bend වෙන්නත් පුළුවන්, චුට්ටක් bend වෙන්නත් පුළුවන්. ඔන්න ඔහම light ray එක bend වෙනවා. Okay. Like this. Then let's say there's another light ray coming like this. A light ray එකත් මෙතනදී මෙහෙම චුට්ටක් bend වෙනවා. Like this. අනේ bend වෙන light rays දෙක, they travel to your eye. You're looking at it from above, so this is your eye. එතකොට තමයි ඔයාට fish ව පේන්නේ. Okay. Up to that point, is it clear? The light rays are traveling from the fish to your eye, and at the surface, the light ray is bending. Okay? Okay. එතකොට, here the bended light ray, you extend it backwards. මේ bend වෙච්ච light ray එකේ හැමම rule එකක් තියෙනවා, backwards extend කරනවා. I'm gonna change this slightly.
Teacher, we have learned this before also.
We have done this before?
We learned it in previous grades.
Huh?
We have learned it in previous grades.
In our class?
No, in previous grades, like I mean in 9.
Yes, in previous grades. No, yes.
The
Yes,
pencil will be looking like it is broken inside or whatever.
Yeah. Refraction ගැන grade 9 වල චුට්ටක් තිබ්බ තමයි. So here the light ray මෙහෙම එනවා. මේ medium දෙක තියෙන change වෙන තැන bend වෙනවා. Another light ray coming මෙතන bend වෙනවා. මේ මගේ ray diagram එකේ චූටි වැරද්දක් තියෙනවා. See? මෙතන මේ light ray එකේ මම arrowhead එක ඇඳලා නැහැ. Arrowhead එක ඇඳේ නැත්නම් it becomes wrong. So you must draw the arrowhead. Now මේ bend වෙච්ච light rays දෙක bend වෙන එකට අපි කියනවා refract වෙනවා කියලා. These are the two refracted light rays now. These are the two refracted light rays. When you extend them backwards, they meet here. Ehang, this is the object, which is the fish. This is the image. Image kiyane what you see. The real object is here, but you see it as if the image is here. එතකොට ඇත්තටම ඔයාට fish ඉන්නවා කියලා පේන තැන නෙවෙයි ඇත්තටම fish ඉන්නේ. Because this is the image, but this is the object. Did you all understand that, lamai?
Yes, teacher.
Yes. So object එක තියෙන එක තැනක image එක තියෙන තව තැනක. So from the water surface to the object, that depth we call it the real depth. From the water surface to the depth of the image, we call it the apparent depth. මොකද ඒක බොරු depth එකක් නේ. ඇත්තටම object එක ඇත්තටම fish ඉන්නේ මෙතන. හැබැයි අපිට පේන්නේ fish මෙතන ඉන්නවා වගේ. So it's not a real depth, we call it apparent depth. Apparent means that's how it seems like. ඒ වගේ තමයි පේන්නේ හැබැයි ඒක ඇත්ත නෙවෙයි කියන meaning එක තමයි කියන්නේ. Right? So this is apparent depth and this is real depth. ඇයි අපිට මෙහෙම පේනුනේ? Because light rays bend when they're traveling from one surface to another. Is this clear to you, Lamai?
Yes, teacher.
Others? Okay. හරි. අපි මේක draw කරගන්න කලින් we'll write a few sentences. Y'all can write with me. මාත් එක්කම ලියන්න. Then we can save time. Give me a second. I'm going to move this a little to the side because I'm going to take this image here. මෙතනට තමයි ඔය image එක draw කරගන්න ඕනේ. Quickly write this lamai. I will give you 3 minutes. Quickly write. Write, make sentences deka and the liwa make a draw kara, and then the last sentence also you write quickly.
Nisha,
Yes, Ashwita.
shall I leave? I don't think.
Okay, Ashwita. Okay. Can you request the recording and get the last bit of it?
Okay, Nisha.
Okay. Others quickly write. Done writing, lamai? Others? The time has gone off. No? Lamai, don't click on the time, okay? The timer is not here. Okay, it's okay. Everybody finished, no? All right. So now we are going to be doing one of the most important parts, right? So here we are going to take a glass block. Excuse me, wait. So we have a glass block like this. Okay. So this is glass. Here we have air and here we have air. Okay. Now I'm going to send a light ray from here like this. Okay, I'm going to send a light ray. Don't draw anything. I'm going to send a light ray like this. When this light ray, now here, air is one transparent medium, glass is also a transparent medium. So the light is traveling from air to glass. So the light ray has to bend, right? So the light ray is bending like this. No, light ray ka bend like this. So if you look at this point where the light ray is bending, මෙන්න මේ ඇවිල්ලා වදින light ray එකට මම කියනවා incident ray. This light ray, I call it the incident ray. This light ray, I call it the incident ray. The point where the incident ray strikes on the surface. මෙන්න මෙතන යා surface එකට වදින්නේ. එතනදී මම perpendicular එකක් draw කරොත් මෙන්න මෙහෙම. I'm going to draw a perpendicular like this. At the point of incidence. මේ perpendicular එකට මම කියනවා normal කියලා. Just like in reflection ළමයා. Reflection වලත් incident ray එක ඇවිල්ලා වදින තැන we call it the point of incidence. Here also when the incident ray comes and strikes on this glass surface, we call it the incident ray. The angle between the incident ray and the normal, we call it angle of incidence. It's called angle of incidence and I use simple I to show that. Up to that point, is it clear? Everybody? Okay. Now it is refracted. ඒ කියන්නේ light ray එක අනිත් surface එකට යන අනිත් medium එකට යන හැබැයි bend වෙනවා. So මේක refract වෙනවානේ. එහෙනම් මෙයාට මම කියනවා refracted ray කියලා. I call this refracted ray. And the angle between the normal and the refracted ray, I draw it using simple R. I indicate it using simple R, which means it's angle of refraction. Angle of refraction. All right, angle of refraction. That's also clear, right? Let's come to this part. මෙතන තියෙනවා glass, මෙතන තියෙනවා air. So then මෙතනට ආවම the light ray will again bend, no? මොකද ආයෙමත් අලුත් surface එකට යනවානේ. So this is going to bend again like this. It's going to bend again like this. If you look at this surface, මේ surface එක ගත්තොත් එහෙම I can again draw a normal here. Again, I can draw a normal here. So at this surface මේ light ray එකට නේද අපි incident ray කියලා කියන්නේ ළමයි. Is that clear to you? I mean, if you look at here, මෙතන බැලුවොත් එම this is the incident ray and this is the refracted ray. But if you look at here, this is the incident ray and this is the refracted ray. මෙතනදී මෙයාට අපි incident ray කියලා කියන්න පුළුවන්. We can call this the incident ray. However, this we already called it the refracted ray. ආයේ මෙතනදී අපි යාට අලුතෙන් incident ray කියලා කියන්න බෑ. So we keep calling this the refracted ray. හැබැයි මේ අලුතෙන් එන එකනට අපි කියනවා emergent ray. Emergent ray. We call this the emergent ray. Why? Because මේ light ray එක මුලින්ම enter උනේ air වලින්නේ. air වලින් enter වෙලා glass වලට ගිහිල්ලා it comes back to air. Therefore we call this the emergent ray. Is this clear lamai? Is that because මේක හරිය step by step තේරුම් ගන්න ඕනේ ඒකයි. Is that clear? Okay. So the angle between the normal and the emergent ray, I indicate with simple E. That means it's the angle of emergence. So I is angle of incidence, R is angle of refraction. Here, this is angle of emergence. Okay. Balanna, here this is 90 degrees, it's a normal. Now, I have a straight line. I have 90 degrees normal, I have straight line. Can you see that these two straight lines, may straight line, may straight line, can you see that they are parallel? Because they are both 90 degrees, can you see that they are parallel? Yes, right? Since this normal is 90 degrees like this, and this normal is also 90 degrees like this, they are parallel. Since they are parallel, බලන්න මේක නිකං alternate angles වගේ නේද? See? They look like alternate angles, Z-shape angles. Therefore, this angle will be equal to this angle. එහෙනම්, since this is equal to R, this will also be equal to R because they are alternate angles between parallel lines. So we have angle of incidence, we have angle of refraction. Medana parallel hinda, alternate hinda, meath angle of refraction. Meath apikena angle of emergence. This is incident ray, this is refracted ray, and this is emergent ray. Is this clear? Is this diagram clear to you? Others? Okay, can you all draw this? Mommy, I think angles to label karna. Simple I is angle of incidence. Simple R is angle of refraction. Simple E is angle of emergence. Okay, these are the angles. Quickly draw this. Make it mommy chuttak vadipura time then now. I will give you vadipura time 4 minutes, 5 minutes. I will set a timer for 5 minutes. Quickly finish. We'll make a finish card. We have a few sentences to write. We'll write those sentences and end the class. Huh? Quickly write this now. Draw and write. Make it fast. Let me know if you're done. Okay. Anyways, the time is up now. I hope you have finished. Okay, let's write a few sentences underneath. Better if you can write with me so that we can save time. Mm, I want you all to focus a bit on the last sentence that I wrote. Let me highlight that sentence. Mediums of the incident, mediums of the incident ray and the emergent rays are the same. So can you see that the incident ray is in air, right? Incident ray is in air, right? The incident ray, this is in air. Can you also see that the emergent ray is also in air? Since the incident ray and the emergent ray are in the same media, we say that the incident ray and the emergent ray are perpendicular to each other. See here, this one is like this, and this one is like this. They look somewhat, not perpendicular, I'm sorry, parallel, right? The two light rays seem a bit parallel. Can you all notice that? ඔගලගේ diagrams වල ඔගලන් ඒ විදිහට draw කරගත්තද කියලා මට sure නෑ, but even if you didn't, can you all maybe erase a bit and make it look like they're parallel, because they are actually parallel. Okay, so why are they parallel? Because the incident ray and the emergent ray are in the same medium. මෙතන air තිබිලා, මෙතන glass තිබිලා, මෙතන water තිබ්බොත්, the incident ray and the emergent ray will not be parallel. Okay, also make them again, because incident ray and the emergent ray are in the same mediums, they are also equal. Angle of incidence is equal to the angle of emergence. Then එකම medium එකේ ඉන්න හින්දා angles also become equal. Angle of incidence is equal to the angle of emergence. Is that clear to you, lamai? Is that clear to you? Okay. Quickly copy these 4 sentences down. After that, we'll end the class. Next week, we will be finishing the lesson. Na? Waves, did I send you a PDF? For the waves lesson, did I send you a PDF? No. Hari, ogala meka liyagan etakang I will. Sorry, etakang I will send the PDF so that I won't forget it later on. I think I told you all last week also I will send the PDF, but I have not sent yet, which is totally my fault. I'm sorry for that, but I will forward it now. Can you all quickly copy down? Lamai, also one more thing that I want to tell you all is that I'm sorry for the delay in starting the class every week. ගොඩක් weeks වල අපි දැන් මං either 7:10 or 7:15 7:30 පොඩක් ඒ වගේ වෙනවනේ classes පටන් ගත්තී. I'm sorry for that. I actually wanted to change the time of the class from 7:30 to 10. Now our time is 7 to 9:30. So I wanted to change it from 7:30 to 10. But then I feel like it will be too late for some of you. With mom personally, done 9:30 is also a bit late, which is totally understandable because you sleep at night, of course. What else? So ඒක හින්දා තමයි මම extend කරන්න නැත්තේ 10 ඒ කියන්නේ 7:30 start කරලා 10 ඉවර කරන එක ඒ option එක මම අයින් කරේ ඒක හින්දා because I mean I moved to Matara, so I need some time to settle. I will try my best to start the class on time from next week onwards, right? So I wanted to apologize for that as well. Up next week, full try කරමු වෙලාවට පටන් ගන්න. Waves. Let me know when you're done writing this, huh? Okay. Anybody who needs more time? Done. තිනුර මේ ওই number එක මට මේකේ වන්න එපා මොකද මේ chat එක නැති වෙනවා. Can you send this on WhatsApp? මම දැක්ක ඔයාගේ number එක change වෙලා තියෙනවා කියලා WhatsApp එකේ මට මේ අර එක පෙන්නුවා. දැන් ඔයා මොකක් හරි number එකකින් you have my number no you are in the group නේ. ඒ number එකෙන් ওই number එක එවන්න hope WhatsApp එකට then we'll add you to the group. Okay? Because I lose the Zoom chat. So send through WhatsApp. Others done? Give me a thumbs up if you have finished. Okay, got it. All right, then let's wrap up. Mayumdi Metna Yashoda.